Hi everyone, and welcome back to another video of IGCSE Math Preparation Series. My name is Irfan, and today I'm gonna continue with previous topic, which was graphs in practical situation. However, today I'm gonna do a bunch of past year paper questions and exam style questions, 4 of which is about speed versus time graphs, and the last two questions is about distance versus time graph. So before I start, actually, I'd like to highlight something. I think it is worth to mention that right at the beginning, because there is a misconception among the students. When they look at the speed versus time graph, they think the curve or the line, it actually implies the path of the journey. Well, which is wrong. That's a common beginner's mistake. For distance versus time, maybe you could say such a thing. If this is distance versus time graph, so let's say the origin represent where you start your journey, like your home. So you travel, you reach your friend's house, you stay there for like 20 minutes, and then you go back to your home. You can say such a thing for distance versus time graph, but for speed versus time graph, if the curve cuts the time axis or the horizontal axis again, like in this case, that doesn't mean that the object is back to its original position where it started its journey in the first place. They even mention in the question, the first sentence, if you read that, it says, the diagram shows the speed versus time graph of a bus journey between two bus stops. So it's not the same bus stop. All right, let's read the question together. This is a diagram. Okay, Hamid runs at the speed of 4 meters per second along the bus route. Okay, he passes the bus as it leaves the first bus stop. The bus arrives at the second bus stop after 60 seconds. So maybe I can draw, okay, the velocity versus time graph for Hamid. So we're gonna get something like this. If his speed is constant, as mentioned in the question, this is going to be the corresponding speed versus time graph for Hamid. And this is actually for the bus. Now, the bus arrives at the second bus stop after 60 seconds. All right. And how many meters from the bus is Hamid at this time? If you think the path, the line that I just drew is the path that he traveled and the bus traveled. So it's the students usually take this value, which is actually 4, and they say, okay, now Hamid and the bus stop are 4 meters apart. That is totally wrong. That's a wrong interpretation of this graph. When we talk about the distance and we have speed versus time graph, we know the area under the curve basically represent the distance. So what you need to do is to calculate the area under the curve for Hamid and also the area under the curve for bus. And that tells us how many meters the bus traveled, and in 60 seconds, how many meters Hamid ran, basically. So for Hamid, the distance would be 4 times 60, that is 240 meters. And for the bus, that's a triangle right there. So you know the formula, half of base times height. Base is 60 and height is 14, right? That's 14 right there. So that means 420 meters. Now the difference tells us basically how many meters from the bus is Hamid right at this moment, 60 seconds. So 420 minus 240, that is equal to 180 meters apart. And remember, both of them are traveling along the same route, right? So I hope it's clear. So don't misunderstand this with distance versus time graph. Their interpretation over there is totally different from what we got here. Okay, I hope that was clear. Moving on to the next question. Another speed versus time graph. Usually these graphs, they actually contain a lot of information, which we need to extract those in order to answer these questions. Cyclist training for competition, and this is the graph, okay, part of the training. Calculate the acceleration. So we know that from speed versus time graph, slope give us the acceleration. They're looking for the first 10 seconds. So this is 10 seconds. All we need is rise over run, right? Or vertical displacement over horizontal displacement. You have to be very careful in counting these squares. So I have 5 small squares between 10 and 20. So each one represents 2 units. So this should be 18 right there. And this is 10, basically 18 over 10, which is 1.8 meter per second square, right? Moving on to the next part. Calculate the distance traveled in the first 30 seconds. Again, this is speed versus time graph. And if you want to find out the distance traveled, you need to look at the area enclosed between the curve and the time axis. So that would be this whole area until the 30 seconds. That forms basically a trapezium, a right angled trapezium. So I hope you know the area of a trapezium, which is the summation of the two bases, right? These two, you divide it by 2 and then multiply it by the height, which is this guy right here, the 18. However, if you forget this formula, which is a plus b divided by 2 times height, so the average of the two bases, if this is a, this is b, and height is clear what we mean by height. So if you forget this formula for the area of a trapezium, don't panic. You should be able to solve this question by basically creating two regions. For example, you can draw this line, and if you do that, it creates two regions, a rectangle and a triangle, area 1 and area 2. That's also another possible way. Since I have written this formula already, so I'm going to use the formula for trapezium. The bases are 30, this guy, and here is between 10 and 30, so this is 20. And 50 divided by 2, 25 times 18, that gives me 450. Since it's distance, it should be meter, right? Lastly, they're asking us to calculate the average speed for the entire 45 seconds. You should know that average speed is total distance over total time. Okay, that's a formula for average speed, not instantaneous speed. For example, right now, if they ask me at 10 seconds, right at that instant, what is the speed of this cyclist? Well, that would be 18 meter per second, right? So we call that instantaneous speed. However, for average, you have to look at the total distance. So if that's the total distance all the way to 45 seconds, it means the whole area, right? This whole area under the curve, this is a trapezium. All I need is the base, this guy, and the height. So half of basically 45 plus 20 times 18, that would be 585 meters, right? So this is the distance. The time taken is 45. So 585 divided by 45 seconds, and that gives me 13. So 13 is the average speed. So the unit should be meter per second. I believe they even provided you with that. Yeah, that's meter per second right there. So that carries 3 marks, that question, because it's a bit lengthy. You have to calculate the total distance and then divide it by total time. Moving on to the third question, we have two different lines. Each of them represent a car, the smaller one and the larger one. What other informations were given? Both of them, they accelerate from, okay, so they are at rest initially because their speed, both of them is 0 meter per second. And then they increase their speed to 40 meter per second. One of them faster than the other. That means it changes its speed at a higher rate and then travels at this constant speed. Okay, so calculate how much further the small car travels in the first 10 seconds. So basically you have to calculate the area under the curve for small car and also for large car and then subtract them. So their difference tells us basically how much further the small car travels, right? So let's go ahead and do that. For larger car, this forms a triangle, right? So half of base is 10, height is 40. So the answer is 200 meter. That's how much the large car travels. The small car, on the other hand, that is a trapezium right there. So what I can do is half of the two bases. This is 10. The top one is basically 10 minus 6. So this distance is 4. I'm sorry, it should be plus, not times. I'm taking average of the two bases. So, and then times the height is 40. So the answer is 280 meters, right, for the smaller car. And how much further it is? Well, the difference of these two gives me 80 meter apart, right? So as simple as that. Moving on to the, that carries 4 marks. So, and it was a little bit lengthy, the calculation. Question number 4, it's kind of interesting because we have a curve here. We never talk about a curve. Well, let's read the question. The solid line on the grid shows the first 10 seconds of a car journey. Describe briefly what happens to the speed of the car between B and C. Okay, B and C, the speed is, okay, there is something you need to know. If this is speed versus time graph, and we are comparing, like we're traveling between 2 points, so you can either have a straight line, or you can go like that, or like that. So concaving up or concaving down, or with just a straight line connecting the two dots. Either way, right, all these three paths, the speed is increasing, okay? But the difference is the middle one, the path number 2, the speed is increasing at a constant rate. So that gives us, for 2, we get a uniform or constant acceleration. And for 1 and 3, we have acceleration, but it's not uniform. So you need to know that the speed is increasing. Okay, so either one of these 3, the speed is increasing. So we have acceleration. It's not really slowing down. Between B and C, the speed is increasing. So that carries 1 mark. You just have to say the speed is increasing. So describe briefly what happens to the acceleration of the car between B and C. So acceleration is the slope. Okay, for speed versus time graph, it's the slope. And for a curve, you cannot find the slope. However, you can find the slope at the point. If I draw the slope for point B, for example, this is what you get. And as you go up, the slope is decreasing to the point at which the speed becomes constant, right? 20 meters per second. That's point C, basically. So after that, the speed is constant and acceleration becomes 0, right? Because a horizontal line, the slope of a horizontal line is basically 0. So what is happening is that the acceleration is decreasing. So we have acceleration, we're still speeding up, but at a lower rate as the speed increases, right? So calculate the acceleration between A and B. Between A and B, well, what you can do if this is A and B, so it looks like a straight line, or you can treat it as a straight line, and you need to find the rise and run. So let me see, B is 15, that's the y coordinate. For A is 5, so the vertical displacement is 10. B is located at here, I think that's 1.8. So A is at 1. The difference is, yeah, 1.8 basically. So 10 divided by 1.8, that gives me 5.6. Okay, all right. Continuing with part 4, using the broken straight line OC, estimate the total distance traveled by the car in the whole 10 seconds. Okay, if we assume this is the path, okay, so we get a trapezium. So forget about the curve. It's a trapezium, and you know the distance is the area enclosed by this trapezium. So half of 10 plus, what is this one? Well, this is C is right at 3. The difference between 10 and 3 is 7, times height is 20. Okay, so I get 10 times 17, which is 170 meter. Okay, explain briefly why in this case using the broken line makes the answer to part 4 a good estimate. It is an estimation because it is not the actual path. This is the actual path. This is a curve, right? That's the actual path. But why is it a good estimation? Well, because if we choose these 2 points and then connect them with a straight line, of course, this area, we're including this area, which we shouldn't, right? However, here we're excluding this area, which again, we shouldn't, right? If we choose this straight line. So we're missing this part and we're including this part. However, if you look at the graph now, we're compensating this part by including this part into our calculation. So we're balancing it out, and I think that's a good estimation actually right there. Moving on to the last part, calculate the average speed of the car during the 10 seconds in kilometer per hour. Don't forget to convert it to kilometer per hour at the end, because we already have the total distance. Average speed is nothing but total distance traveled divided by time taken. The total time is 10 seconds, and that gives us 17 meter per second. But don't get too excited and move on to the next question. They want the answer in kilometer per hour. So what you can do is you multiply this. I'm going to use the space here. 17 meter per second is equal to, so meter is actually 1,000th of kilometer, and seconds, because 1 hour is 3,600 seconds. 3,600 goes there, and this should be per hour, right? And eventually you get the shortcut that I told you, just multiply it by 3.6 and you get 61.2 kilometer per hour, right? So the conversion of meter per second to kilometer per hour, the shortcut is just multiply by 3.6. And if you want to convert kilometer per hour to meter per second, just divide it by 3.6. And where that value comes from this conversion that I did up here. All right, moving on to the next question, question number 5. Now this is a distance versus time graph. We have to be very careful. So let's start with the question. The graph shows part of Ali's journey from home to his school. Okay, this is home. This is the school. Okay, so that is 900 meters apart. He walks 200 meters to his friend's house and waits there. He then takes 20 minutes to walk with his friends to their school. So I think that is also clear that here at this part, because he's not moving, there is no motion. This is where he's waiting at his friend's house for duration of 5 minutes. And then at this point, both of them, they start walking towards school. That takes 20 minutes. So let's see, from 8:10, okay, 20 minutes, it means 8:30, they should be at school. They said complete the graph. All you have to do is just connect these two dots, right? That's not really a difficult task to do. Just make sure you count the 20 minutes first, just because they put the scale here, that doesn't mean the graph should actually cover the whole grid paper, okay? So maybe they stop here, we don't know. So just double check that. How long does he wait at his friend's house? Well, that's 5 minutes. That's very clear. Next question. How long does he, I'm sorry, that question is repeated. Calculate the average speed for Ali's complete journey from home to his school. Give your answer in kilometer per hour. So average speed is basically total distance over total time. Now, in this case, you do not need to actually find the area under the curve, because this is already distance versus time graph. So we know there is 900-meter distance, right, between his home and his school. That goes here in the numerator, distance over time, and the time is basically 30 minutes. Since they want in kilometer per hour, so, and this is 30 minutes, I'm gonna convert this to kilometer, 0.9 kilometer. 30 minutes is half an hour. So if you calculate this, you get 1.8 kilometer per hour. All right. So average speed means total distance over total time, even those time that he made a stop. You have to include those time as well. So that's total time. Okay, be very careful. Don't just count for the time that he was moving. Okay, moving on to the last question. Okay, this is again a distance versus time graph. This is about Sonia's journey from home to the library. So this is library, and okay, that is 5 kilometers away from her home. She walks to the bus stop first and then waits for a bus. Okay, and then to take her to the library. The distance to the bus stop. So this is the bus stop. Why? How do I know this is the bus? First of all, they mention it, and it's also clear that she waited basically 15 minutes there, right? This is 30, this is 35, so 15 minutes she was waiting there. So the distance is basically this guy right here, 1 kilometer. That's the answer, 1 kilometer. How many minutes she waits for a bus? 15 minutes. How many minutes the bus journey takes to the library? So this is the bus stop, this is the library, and this is the time that it takes, basically from 35 to 45, which is 10 minutes. Calculate in kilometer per hour Sonia's walking speed. She walked for 20 minutes and the distance she covered was 1 kilometer. 1 kilometer divided by 20 minutes is, you have to convert 20 minutes to hour. So basically it's 1/3 of an hour, right? Because 1 hour is 60 minutes. So 20 minutes over 60 minutes is 1/3, all right? So you divide that by 1/3 of an hour and you get 3 kilometers per hour. That's the speed that she was walking. And the speed of the bus, okay, it should be way higher than this. It's obvious from the slope of this line. That's way steeper than this stage. So again, same thing. We need to find the, okay, another misconception here, another mistake that the student make, they actually calculate the whole distance from home to library. That is wrong. Only for this stage, okay, the vertical displacement and horizontal displacement. That means 5 minus 1, this is 4, and 45 minus 35, so this is 10 minutes, right? So this is 4 kilometers and 10 minutes. Again, you have to convert 10 minutes to hour, which is 1/6 of an hour, right? 1 hour is 60 minutes, so 10 minutes is 1/6 of it. I think that's very clear. So this is 24 kilometers per hour. That's for the bus, and this is for Sonia's walking speed. The last part, the average speed for Sonia's journey from home to library. So average speed means total distance over total time. So again, don't find the area under the graph. That is wrong. We don't do that. That was for speed versus time. Here you already have the distance between home and library. That is 5 kilometers. And the time taken is basically 45 minutes. 45 minutes is 3/4, right? 3/4 of an hour. This is equal to 45 minutes. So you divide it by 3/4, and the answer you get is basically 6.7. You round it to 1 dp, and that should be kilometer per hour, right? Or 20/3, right? If you want to leave it as a fraction. All right, Sonia works in the library for 1 hour. So this is the part I believe that we have to complete the graph. Yeah. So works in the library for 1 hour, then she travels home by car. The average speed of the car is 30 kilometers per hour. Let's go ahead and actually apply this information on the graph. Waits there for 1 hour. So right now we're at 45 minutes plus 1 hour. It should be meaning which plus 60 minutes. We should get to 105, right? So this is 45 minutes and this is 105. And the distance between them is basically 60 minutes or 1 hour. And then from here, she goes back to her home and the speed is 30 kilometers per hour. So again, don't just connect these 2 points. We don't know that. The slope of that line should be 30. Now, let me see. The distance is 5 kilometers. So from the equation of speed is equal to distance over time. Speed should be 30 kilometers per hour. Distance is 5. And we can find time basically from there. So time is 1/6 of an hour or 10 minutes. So after 105, just 10 minutes after that, she gets home, which is 115. So you see, you didn't have to draw that line and connect it to 140. That was wrong. So this is the correct path, and this is the wrong one. Okay, so be careful. You have to calculate the time using the equation of speed. Having said that, I think this is a good place to stop. I hope you have enjoyed this video. Please don't forget to drop your comments below. Stay safe, and I see you guys in the future videos.